Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video I want to talk about arc length and area of a sector. So just a couple definitions as we begin the video. First of all, what is a sector? It is just a region of a circle that is bounded by two radii and an arc of the circle. So if we see in our diagram down here, the shaded part is our sector. We see that right here. And now what is a central angle? Well, central angle is most often denoted by the Greek letter theta. And it is just the angle that's formed by the two radii. So our central angle would be our angle in here. So a couple other things, we have arc length. So that's the length of our arc over here that is intercepted by the two radii. And then we have r right here that is denoting our radius. So the two formulas that we want to know, one for arc length is just S is equal to r times theta, and theta needs to be represented in radians. So for example, or in the example that we're going to look at today, if our angle is 90 degrees, we would write that as pi over 2 instead of 90 degrees because we want to have it in radians and not degrees. Then for area, we're going to say area is equal to 1/2 times the radius squared times theta. Once again, also theta in radians, okay? So the example that we're going to do in this video is involving a baseball field. So I'm a former baseball player. I love the game, played it my whole life. And this is actually the Kansas City Royals Stadium, Kauffman Stadium. So I've been to Kauffman Stadium, actually played there, not for the Royals, but when I was in high school, I had the opportunity to take batting practice there, actually hit a home run at the field. So a lot of good memories there. But the real reason why I chose Kauffman Stadium is because their outfield fence is one of the more symmetrical outfield fences in Major League Baseball. So if you know anything about Major League Baseball, the fields, there's not like one uniform dimension that the fields have to be. And so you'll see a lot of different designs and the fences and all of that kind of thing. And so for this one, it's pretty standard, it's pretty uniform. But if you notice here, in this little area right here, it does kind of bow out a little bit. So the calculations that we're going to do in this video probably are not exactly correct for the length of this fence, but it should be relatively close. All right. So now what we need to do, first of all, is we need to know the dimensions of the field in terms of like the distance from home plate to the outfield fence. So that's going to be this distance here and also this distance right here. Okay. So another reason why I chose Kauffman Stadium for the Kansas City Royals is because these distances are the same. They are 330 feet. So that's a pretty standard distance down the foul lines is what it's called. So the left field line, the right field line, they are the same, 330 feet. And like I said, that's not always the case in all of the different Major League Baseball stadiums or really any baseball stadiums you might go to. So that's why I chose this one. Now, another thing about baseball, there's a lot of angles and degrees and all of that that's involved. So it's a pretty cool game if you like math. And so the angle that's formed right here is actually a 90-degree angle. So our central angle for this example is going to be 90 degrees. So we want to find the length of the fence. So that's going to be this length right here. And like I said, it's not a perfect arc as in like a perfect piece of a circle, but it's about as close as we could get in terms of an actual baseball stadium. And that's what I wanted to use in this video. So now we're going to use our formula up here. Arc length is just S equals R times theta. So arc length, and it's going to be S is equal to R times theta. So we're going to say S is equal to, so our radius in this case would be 330. And for theta, it's 90 degrees, but we want to write it in terms of radians. So that's going to be pi over 2 radians. So we can use our calculator for this, and let's just round it to the nearest whole number for feet. So we're going to do 330 divided by 2, and then we'll times that by pi. Okay, so basically we're doing 165 pi. So S equals 165 pi. So we're going to say that's approximately 518 feet. So the length of the fence from the left field line to the right field line should be close to 518 feet. All right, now so that was arc length. So now for the area of the field. So this is going to be the area of what's considered the fair territory. So all of this area inside here, because notice we do have a little bit of area out here. That's considered the foul territory. So if you want to know what that is, you can look up a little bit about baseball. But for purposes of the area, we're going to be finding the area of the fair territory. So once again, this is going to be approximate because the exact dimensions of the outfield fence is not a perfect circle, but it's pretty close. So we're going to use 1/2 times r squared times theta. So area is equal to 1/2 times r squared times theta. So we have 1/2. Our radius once again is 330, and we're still going to use our pi over 2, our radian measure for 90 degrees. All right, so in our calculator, 330 squared is 108,900. If we divide that by 2, that'd be like by multiplying by 1/2, then we'd get 54,450 times pi over 2. So let's divide that by 2 again. And we're going to get area is equal to 27,225 pi. So we'll multiply this by pi, and we'll find to the nearest foot. So to the nearest foot, we're going to say there's about, or to the nearest square feet, about 85,530 square feet of fair territory at Kauffman Stadium in Kansas City, Missouri. Okay, so hopefully that's a pretty cool connection between math and baseball, and that's how you can find arc length and area of a sector.